Hello and welcome once again to CaptainGoodspeed Maths. I'm Joe, if you're new around here, and today we are focusing on some more OCR FSMQ, the new spec, with the exam approaching fast next week. I've had a couple of questions. All of these lessons will be uploaded before the exam next Tuesday, do not worry. There's about 5 or 6 to go. My plan is to record and upload a couple every day and get them up by Sunday at the latest. So if you're watching this in the future, ignore all of that. Today we are talking about the decimal search as part of the numerical methods part of the course, and the learning objective is to understand how to show that there's a presence of a root between two values using the method of decimal search. Pardon me. But this is something that I've never actually done in maths before. In my 15-20 years study of the subject, I've never come across this before, so it's a new thing for me and a new thing for all of us today going through it. So last time out we looked at something called interval bisection. If you haven't seen that, then there is a full playlist of all of these lessons, and you can go and see what that's all about. This time we're going to be looking at the method known as the decimal search. So this is where we systematically increase the number of significant figures to which the root can be quoted. So the examiner will tell you exactly how many sig figs they want from you, but as you'll see, it's very, very easy, this method. So example 1, show that there is a root in the interval 1, 2 for the function x cubed minus x minus 1 equals 0. So this is exactly what we were doing in the interval bisection. This is the first part of the question. So what do we know about the root? Well, we know where x is equal, well, it's not where x is equal to 0, it's where y is equal to 0. That should be a y there. Apologies about that. Where y is equal to 0, i.e. where it crosses the x-axis. So we know that as it heads towards the x-axis, it's either positive or negative, and once it crosses the x-axis, it will be the opposite. So think about a graph. The line comes down, it hits the x-axis at y equals 0 from the positive area, and then it'll go into the negative, and vice versa. If it comes up from the negative, it'll hit the x-axis, then go into the positive, unless it's a cubic graph or something like that, but we'll think about that later. So therefore we're looking for a change of sign when we put the two numbers through the equation. As we'll know, the point it is equal to 0 will be within the interval. So we did all this last time out. So we put 1 through and we got -1, we put 2 through and we got 5. So we know that somewhere in between there it has hit the 0 point. We have a change of sign, which implies that there is a root between the interval 1 and 2. We did exactly the same thing last time out. So what the decimal search allows us to do is make this interval smaller and smaller, increasing the accuracy. So the sub-question to this would be to use the decimal search to find a root interval of 0.01 width. So last time we did interval bisection, we were halving the interval each time. This time we're looking for a much more precise width of 0.01. So from the first part, we know that f of 1.0, if you like, is negative. So let's increase by 0.1 until we get a positive value. So we start at f of 1.1, so we do 1.1 cubed minus 1.1 minus 1 is minus 0.8. We do for 1.2 and get minus 0.5. We do for 1.3 and get minus 0.1. We do for 1.4 and we get 0.3. Bing, 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 bing. Bingo. We now know that the interval is actually between 1.3 and 1.4. So already you have gone from a width of 1 to a width of 0.1. The examiner wants 0.01 though, so we have to keep going. So this time we'll increase by 0.01 each time from 1.3. So let's do that here. Haven't animated that. Spoiler alert, everyone, don't read the bottom. F of 1.31, we stick that in and get minus 0.06. F of 1.32, we get minus 0.02. And F of 1.33, we get 0.02. So there you go again. Aha! We now know that the interval is actually between 1.32 and 1.33 because there is a change of sign between those, and that is a width of 0.01. So that is your interval. we know that 1.32 is less than x is less than 1.33. So x is trapped between that interval somewhere. Now, they might ask for 0.0001. You just have to keep going and just increase by that sort of next width, if you like. But you just keep going with that procedure, and it's easy peasy. Squeezy lemons. But there you go. That is it. That is it for decimal search. It is as easy as that. All they can do really is increase this width or decrease it, as it were, to add another decimal place, and you just do the same thing again. Go through it at your own pace and try and get your head around it if you don't understand it. If you found it helpful, then make sure you leave a like down below. If not, then let me know down in the comments what I can do to explain it a bit better. Remember that this lesson is in the description to this video. All the other ones are on the Google Drive. Go to that specific video, hit the link, and it'll be there. I am hoping to get them all in one folder though, and get that updated before Tuesday's exam. So subscribe for more FSMQ content, and of course, best of luck with your exam.